Today we're going to be talking about how to prove a triangle is congruent, and we're going to be using the 5 congruence conjectures that we've talked about so far in class. Remember, the first one was side, 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 and that's when you have 3 pairs of congruent sides. So your triangle would be marked with 3 sets of congruent sides, and remember, each set of sides gets a different amount of tick marks because they're all different, could be different lengths. The second congruence conjecture is side, angle, side. Don't forget that the angle has to be in between the 2 sides. So this is where 2 sides and an included angle are congruent to each other. So I'm going to have, and remember this can be anywhere on the triangle. I'm going to have this set of sides congruent. That's your first side. Then I'm going to have, say, this set of sides congruent. That would be that second set of sides. Then the angle has to be right in between them. So if these are my 2 sides, it has to be this angle that is directly in between them. The third congruence conjecture is angle, side, angle. Remember here the side has to be right in between the 2 angles. Again, this can be marked anywhere on the triangle, but if this set of angles was congruent to each other, those corresponding angles, and then say this top set of angles were congruent, those are my 2 sets of angles, therefore the side has to be right in between them, which would be that side's congruent to that side. The third congruence conjecture is angle, angle, side. Here the side is not in between the angles, so it's 2 angles and a side opposite them. So I could do this angle is congruent to this angle. Again, this top angle is congruent to that top angle. And then the side would be this next side, angle, angle, and then you would have a side, set of sides congruent. And then the 5th congruence conjecture is the one we talked about the other day. It's the hypotenuse leg. Remember, the hypotenuse leg only works on right triangles, and it says that the hypotenuse on both triangles has to be congruent in one set of legs. So the hypotenuse, remember, is the side across from the right angle. So this side and this side would be congruent. Those are your hypotenuses. And then one set of legs. The other 2 sides that make the right angle are your legs. Either set can be congruent, so we could just say that this set would be congruent to that set. Now, we're about to get into writing some more proofs with proven triangles congruent. So, a few reasons. This is kind of like a little checklist or a cheat sheet to help you with these proofs. So, some reasons that your sides would be congruent. If you're trying to prove sides congruent. In your proof, it could be given information. We always like that. That's the easy part. Another thing that makes sides of a triangle congruent is if you have the definition of a midpoint. If you have a midpoint, then that breaks up your side or your line segment into 2 congruent parts. Or the reflexive property. Okay, that means that one side is equal to itself, which is where 2 triangles may share a side. That's where that reflexive property comes into play. Okay, and then some reasons that angles may be congruent. It may be a piece of given information. Angles are also congruent if they are vertical angles. We already know that piece of information. Angles can be congruent if they are alternate interior angles, alternate exterior angles, or corresponding angles. Now, the only way that you can have any of those 3 is your lines you must have parallel lines in your picture. If you don't have parallel lines in your picture, you can't use alternate interior, alternate exterior, or corresponding, because those are only true if you have parallel lines. And then the last reason that you could have congruent angles is the definition of an angle bisector, which means that a line cuts that large angle into 2 smaller angles or into 2 smaller congruent angles. Therefore, those 2 angles would be congruent. And then the last little thing that you need to know for proofs is something called CPCTC. And it stands for corresponding parts of congruent triangles are congruent, which means if I know my triangles are congruent, I know that my corresponding 3 sets of sides and my 3 sets of corresponding angles have to be congruent. So if we look at this picture, let's talk about if these 2 triangles are congruent, and it says if triangle ABC is congruent to triangle DEF, so I do know that they're congruent, then we can name the 6 sets of corresponding things. So if I'm talking about angles, I know that angle A would be congruent to angle D. Okay, so I can mark it in my picture. Those are congruent. I also know that angle B is congruent to angle E. So I can mark that in my picture. And then lastly, I know that angle C is congruent to angle F. And I can mark that by 3 arcs, showing that all sets are different measurements, but corresponding angles are congruent. Then we also have corresponding side lengths, such as AB is congruent to DE. Then we have, so I can mark that AB is congruent to DE. Then we have that BC has to be congruent to EF. We can mark that by 2 tick marks because it's the second set. And then the last one would be AC is congruent to DF. And since this is our third set, this would get 3 tick marks. So all of these things that we need to know for proving triangles congruent, we need to know our 5 conjectures: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. We need to know some reasons that our sides might be congruent or reasons that our angles are congruent. We've talked about all of these in proving things before. And then the last new thing is the CPCTC, corresponding parts of congruent triangles are congruent. Again, if I know my triangles are congruent, I know that all 6 parts, corresponding parts, are congruent to each other.